Hello and welcome to our final session from Automotive EV this week. Really hope you've enjoyed the session so far. We've got a cracker for you here, just to close out the week. Taking you through this with David Hudson and Matt Bloomfield is Professor David Greenwood from Warwick Manufacturing Group. It's going to be a broad spectrum discussion about the future of automotive EV, where it's going, and I'd like to pass over to David to take you through this. Thank you.
Thank you very much, Sean. So welcome everybody to this Friday afternoon session, leaders event looking at the future of electric vehicles. And we've got some great people here to help to walk us through that. My background, my name is David Greenwood. I run the Advanced Propulsion Group at the University of Warwick. So we have researchers looking at batteries, motors, power electronics, and all of the parts that you need to bolt those together to make electric vehicles. We do a lot of work with UK government through various research and development activities. Please, first I'll ask the other panel members to introduce themselves. So first, if I could hand over to Matt Bloomfield, please, from Lotus.
Okay, I've got some presentation content to share, so if I can just share my screen.
We can see that well.
Okay, unfortunately it started on the last slide, so let's go back to the beginning. So, thank you for the introduction, Dave. My name is Matt Bloomfield, and I'm the Chief Technical Specialist for Propulsion and Electrical Engineering at Lotus Cars. The interpretation of that role is different around various different companies. So for Lotus, that means I look after our teams effectively. There's really two things that I'm charged with ensuring. I need to make sure our teams are enabled, so they've got the right tools and training and support, and they're appropriately targeted. So have we got the right technical definition of all the systems that they're responsible for delivering? And we achieve that through research, industrial and academic engagement, and that's really what I look after.
Thank you very much, Matt. And David, could I ask you to introduce yourself, please?
Yeah, absolutely. So I'm pleased to be back for a second round in this event. So I'm Dave Hudson. I am the head of Vehicle and Powertrain Engineering for Tata Motors European Technical Centre. We're based on the same campus as Dave Greenwood's group, so at Warwick University, and we provide some advanced engineering services for Tata Motors India operations, where we are making cars and trucks, and have been doing so for the last 60 odd years. So no manufacturing operations here, it's all R&D. For the last 10 years or so, we've been very heavily focused on the new trends, the ACES trends, so electrification. We had an EV in the market 10 years ago, and now we've been working on connected autonomous vehicles as well, so a pretty broad spectrum, but all focused on passenger cars for Indian markets and other South Asian markets.
Thank you very much, David. What I would say is if anybody has any questions as we move through today's proceedings, then please do put them into the chat and they'll be sent through to me by the organisers, and I'll make sure that we raise those. The format for today's session is really a rather informal chat around what the future holds for electric vehicles, around technology, around infrastructure, around markets. So if you have any questions on any of those, then please do feel free to put those into the chat. So perhaps to start with, Matt, let's talk about the technology. You know, Lotus has always been a leading edge technology company. If we think about what's happening for electric vehicles, there's a pretty good understanding as to what today's cars look like. We may come back later on to what Elon Musk has put forward on his battery day as to what he thinks the future looks like. But what's your view of the direction in which the technology is going to move for electric vehicles?
Okay, well, that's a... The wonderful thing about this area is just how varied that question is. It depends completely on your market segment, your product, and what customers you're aiming at. So for Lotus, we are looking currently with the Avaya that we're about to launch for in the electrified vehicle market. We're looking very much at the performance and hypercar segment. As we move forward, that's going to come down. So the Avaya is nearly ready to launch. So our focus has moved more from hypercars in engineering day-to-day activities into higher volume. Now, if we look at the performance side of things, we can look at power density, and we consider batteries. They're conceptually the enemy of power density in what we see in most applications for electrified vehicles. However, over the last 10 years, the pace of development has been astonishing. And if we look forward at all of the things that we're regularly bombarded with through various media channels and research entities and companies, there's so many things and such a rich variety of areas that people are looking at to improve batteries. And then moving to something slightly different, we've got electric machines. Again, there's a range of developments going on there. It may be less obvious from the outside world because a lot of the machines do look relatively similar, but there's some new architectures coming, and then there's materials developments as well. So there's opportunities that we're yet to see the most out of yet.
Thank you very much. And I'm just going to move over to David, because I think the point you raised around market segments and the fact that there's different drivers in different points, I think, having spoken earlier, David, that's an area that's close to your heart.
Yeah, indeed. It's great that that we've got what I once saw in a road and track presentation at a battery conference or an EV conference being referred to as the red meat EVs, the ones that would appear on the covers of the magazines with tyre smoke. So we've all seen those, and they're great for grabbing headlines, and for a very small handful of very wealthy people, they're great fun things to own. But the reality of the drive to electrification is truly not about those cars. It's that they're the market leaders, they may be the technology leaders, but actually the mass market is going to have to be satisfied by much more modest vehicles. And I think the key issue is that with the growing motorization of the eastern half of the globe, and in particular the Southeast Asia growth, China we've already seen come and become market leader, or total volume leader, but India, our home market, is forecast by most analysts to be heading for being the third largest market after China and the USA. It'll happen in maybe 10 years' time, but that's where the growth is. And we're talking about vehicles for people who are not as wealthy as Western buyers and operating in much more constrained conditions. So not looking for extremely high performance vehicles, but certainly conscious of low operating costs. So I think the story that we're pitching with EV today, that perhaps acquisition price is still a little bit on the high side, but total cost of ownership. I've seen a number of analysts now, including Frost and Sullivan, talking about really cost parity now when it comes to TCO, even in most markets with most electricity prices. So that's a really important point, because if we can convince people that we've got that and we can keep the capital cost of some elements of the EV sector low, then we've got a chance of getting high volume of cars into the market. And as long as those cars don't have excessively large batteries, we might do so without flooding the world with too many gigafactories. I know we need a few, Dave, but we need to spread the battery layer a little bit thinner in order to satisfy those markets. It's also important that those markets have got a pretty vibrant second life opportunity, because many of those markets are places with big rural populations, and those we see as very important outlets for second life batteries, and also local reinforcement of grids to support the first life batteries in the EV.
So I think one of the interesting points that you raised there is around, for the average car, we'd all love to be driving the kinds of things that Matt's company is producing, but unfortunately most of us don't. And so for the average car, we do need to find a way of getting the acquisition costs down. And to me, it seems that there's an interesting play here between the infrastructure and the vehicle itself. So at the moment we package large batteries into vehicles because we have to. The infrastructure is sparse, the charging times are long, and therefore the best way for us to get a user experience which is acceptable is to package a large and expensive battery in there. Now I think if we fast forward to a better infrastructure which is less sparse, you could argue that small batteries which charge quickly could be a nice way of bringing that cost down. How far do you think that we can take that trend? How much do you think we can reduce the range or the cost of a battery?
That's a leading question. I mean, I think we're already seeing that perhaps more modest battery chemistries are being revived, and the revival of interest in LFP technologies, which we kind of put on the shelf for a while because of the great advantages of NMC in terms of their energy density. For a number of reasons, we're seeing those come back, and obviously the ethical reasons are not related to technology, but also the fact that we're putting batteries into the hands of relatively, amateur users in many cases, and the inherent greater safety of things like LFP are also, become factors. And I think if we follow those kind of trends, it does help us to crack the acquisition cost story somewhat, but also as I know there was a specific session earlier this week that referred to the Battery Day announcements from Tesla, and I think Tony Harper talking about that said, although the shareholders seemed disappointed by an announcement that wasn't packed full of tech, it actually was a sign of growing up, because most of the story in there was actually about manufacturing, and it was about how to improve the output of a factory that is making batteries with relatively conventional chemistries, and putting them into form factors which are more suitable for cars. So not laptop batteries, which I think was inevitably a short-term equation, but to find ways to make these batteries more speedily and more reliably. And so I think all those things are working together. And if Mr. Musk's 56% or whatever it is that he's forecasting as an improvement is actually on the cards, that for me is very exciting for our cars, because it means that the battery costs, which we're seeing as in some cases 2 or 3 times the cost of the rest of the vehicle put together, may actually come down into something a little bit more like the slides that you put together, Dave, with 50% of the car being the battery. At the moment, it's much more than that for us, because we have a very frugal supply chain for the rest of the car. So I think there's light on the horizon, but of course it's the usual thing. We have to commit volume before we get the volume benefits, and we can only commit volume if we've got sales, and we only get sales if we've got the cost. So there's a few acts of faith needed to kickstart and people to really promote the product. But of course, that's where our recent post-COVID recovery story may actually perversely help us, because people can now see the path to better air quality, for example, and that may be the impetus that we've just felt has gone out of the market. So sorry, I've covered a lot of ground there, but
yeah. So I mean, one of the key points that you made there was around, if we do move to some of the less kind of, I'm going to refer to them as less exotic chemistries, more cost effective, not necessarily the massively high energy densities, but the thing that gives what's needed to every person. And you could see a market moving in that direction, Matt. So what does that mean for you guys? Because if the battery industry is then heading off in this direction of low cost commodity, what does that mean for the ability to still make cars that have the performance that you guys are used to?
Well, so I think we've seen recently the exploitation of the improved safety characteristics of LFP for recovering some of the loss in energy and power density relative to a a different chemistry solution. So it's not as bad as it would seem from just comparing energy density of chemistries, and we're yet to see just how far we can push that. And there are things going on to look at how much further we can push LFP energy density and how we can make it an even better proposition at pack proposal. It was another thing that came out this week, was the functional integration of protection systems into vehicle structures, which working for Lotus, it's really nice to see that being pushed, and we start to see less functionally redundant structural members in vehicles as we move forward. This is a very good thing and a very good influence on our engineering teams. So yes, it's not as bad as just comparing chemistries would seem.
And traditionally, motorsport and high performance has generated the technologies which have then filtered down for benefit in mass market cars. Is that's a trend that you see continuing, is it? And are there particular areas of that you'd be focused on? You talked about your own company's journey to move from the real, the high performance niche into the larger volumes.
Absolutely. So a thing that I'm trying to get traction within Lotus is doing more with less, and that applies to absolutely everything. So if you truly understand your problem and you solve it in the most efficient manner to generate high power density, high performance, for example, in electric machines and batteries, if you're fundamentally controlling your generation of heat and the ability to remove it from your active materials or your coils, so it's not going to the wrong place, sending the active material too high or getting magnet temperatures too high. If we're solving those fundamental problems and making things simpler and not more complex, then we're reducing the cost and making it smaller and using less materials. It all contributes to something that's more usable for the very lowest end of vehicles.
I guess one of the things I see as quite interesting is that as we move to electric vehicles, the torque characteristics and the power characteristics that you see of an electric vehicle means that performance is almost becoming a commodity. Your average electric shopping vehicle will out accelerate a BMW S1000 RR motorcycle. And so in that kind of market, what do you think is going to differentiate things like the Lotus products in that way?
Oh, that brings us to a wider set of automotive trends and infotainment and features and vehicles on demand, but specifically from the powertrain, there's things we're looking at to generate driver engagement. I used to have a Honda S2000 and I never got out of that thing without a smile. So replicating that sort of engagement and emotional response with an EV, that's an opportunity for Lotus to differentiate ourselves. And then comparing other vehicles that are on the market, we've already touched on functional integration. I mean, structurally as well as physically, that there's a lot of opportunity there. Electric machines, again, if I compare what we're looking at now with what's on other roadmaps and hinted at in job adverts for people's research teams, there's a lot of opportunity there relative to other OEMs. So we've got the opportunity to generate a real differentiated product offering through the technology we have in our EVs.
And I guess one of the things that motorsport brought to road cars before was very much it's around efficiency. It was getting every last bit out of that the gallon of fuel or litre of fuel that you were burning. And with electric vehicles, we all know that the secret to keeping the battery cost low is to have the vehicle as efficient as possible. Do you see that as being a continued trend from motorsport downwards, or is it going to flip the other way, do you think?
So if I look at motorsport and electric machines, I immediately end up thinking cobalt laminations. Let's whack up the magnetic field density by 30% and more torque with the same size machine. But that's horrendously expensive, and we don't like cobalt from batteries, as we readily know. So perhaps motorsport isn't the source of our next generation of electric machines. However, that's not to say there isn't really useful learning. For example, if I compare energy usage and oil volumes in some motorsport applications to road applications, it's night and day difference. But we've still seen that we can see a very, very small amount of oil going a very long way and having a large effect on the overall efficiency of a drive unit. So there's some learning to be had from motorsport, but not all of it.
And David, I know that efficiency is something that's quite close to your heart on this. I don't know if now's a good time to put some of the slide material that you'd prepared up.
Let's share a few slides. Anybody who had previously joined the session on powertrain earlier this week will find one or two of this a little bit familiar. Am I sharing correctly there?
Yeah. Yes, we can see you well.
Right. Okay. So, the story about global adoption is going to, in my view, have a lot to do with efficiency. So the slide that I shared the other day was, and I apologise to those of a academic bent for the mixture of units here. We've got miles, we've got kilowatt hours, we've got grams per kilometre, we've got horrible things going on. Anyway, the data was actually, the data points are from the EPA database, because sadly it's the best organised one in terms of vehicle efficiency that I've found. But what you're seeing is battery size against range. This range is on the EPA cycle, so it's somewhere close to WLTP and certainly a lot better than NEDC in terms of representing real world. And what I've done is, hopefully by the correct mathematical process, put on an equivalent line for what 100 grams per kilometre would mean in an IC engine. And then also another line which kind of bounds it, which happens to be 30 grams per kilometre. So there's a scatter of points on there which show that that there is significant difference between EVs that are in the market today. And interestingly, the more frugal EVs, the ones with smaller battery packs, do tend to hug the line that's up towards the top part of the graph. So, obviously the developers of those vehicles are aware of the efficiency issues. The scatter at the top with the larger battery pack vehicles are probably more of the vehicles where range was not the highest ranked attribute, where something else was in the way. So, I do think we need to think about this mile per gallon equivalent, and I think it's language which I know EPA took quite a long time to develop the right equivalence ratios and to make it compatible, but it's resulted in well-informed consumers, because they can walk into a dealership and they can see a range of vehicles ranging from completely conventional non-electrified vehicles through mild, through strong hybrids, up to full BEV, and they actually get a pretty fair indication of what the energy efficiency of those vehicles looks like, in the same way as we would if we were buying a refrigerator or something like that from a local electrical retailer. So, when you start, we've all got used to the grams per kilometre number, because we, either pay taxes based on it, or we pay our road fund licence based on it. But I think in terms of EVs, because everything below 100 grams is free to use on a tax basis, we tend to not think of there is such a thing as better and better. And what I've done here is I've also extended this graph a little bit now, because recent announcements and developments mean that 350 miles range is no longer enough to describe the majority of EVs. And at the top right, we see a star point out there for our friend Peter Rawlinson, who's been talking about the Lucid Air product, which is a very uncompromising vehicle, but which has had efficiency as an absolute watchword. And they've just done a bit of marketing based on standing quarter mile, so 9.2 second quarter mile, 157 mile an hour terminal speed. That is quick for any kind of car. I think they might have unseated the Dodge Demon, which is 7 litres of supercharged V8. Also, we've got Matt's offering there of the Lotus Evija, nicely in the middle of the of the spread. So, you know, we could say at the moment we've got hypercars that are really exceeding all our expectations. If you think, you know, the hypermilers, the people who are looking for the absolute best efficiency, we've now got both the Hyundai Ioniq EV and Tesla Model 3 offering numbers above 130 miles per gallon equivalent. So, you know, we're doing that quite well. My argument is that we need to find a spot that's actually a little bit away from those vehicles. And you know, if you want to put some numbers to it, and as I say, apologies for the mixed units, but 200 miles or, you know, 300 kilometers is a pretty good number. If we can do that off the back of 30 kilowatt hours, so, you know, 10 kilometers per kilowatt hour as an index, that would actually get us right in the game as far as a lot of the emerging markets were concerned, and I think make people in mature markets actually feel that they would be motivated to drive less you know, less over batteried EVs, because they will actually become in real terms cheaper than the, you know, the chemistry sets that we've had to turn IC engine cars into over the last few emission cycles. And I think that will really open up the market. And if we can see that the, you know, the cluster of points on this this graph, if over time all those points migrate sort of towards the top left of the curve, I think that as an industry we'll have actually done some innovation for good rather than innovation for the sake of you know, a whole range of interesting but not necessarily valuable attributes. So, you know, efficiency, you know, I might add a little sort of a curtain opening here, but, you know, to me, efficiency is the key. That as engineers, we've been driving towards efficiency in lots of things we've done. So, you know, Matt talked about structures, you know, structural efficiency, you know, having shared a small part of my life with the team at Hethel, you know, there was massive pride at the structural efficiency of what's become a, you know, the whole generation of Lotus products with Elise and the Evora family. That's what it's all about. You know, it's the Colin Chapman ethos. You know, use as little as you possibly can to get the job done. And I think now we understand electrification commodities a little better. We started off by spraying far too much around of everything. You know, whether it was rare earths in magnets, whether it was conflict materials in batteries. And now that we've got them out there and we've said this isn't enough, we've actually got to work on joining them together in a much more effective way. And that, to me, is where the efficiency story comes.
And what that would get us looking at those plots is, you know, if we talk about total cost of ownership, we talk about even just purchase price. When do you think that gets us to equivalence? You know, we've got Tesla talking about having a £25,000 vehicle or sub £25,000 vehicle out there around 2023 or thereabouts, which would be right in the mix with a conventional IC engine. How far away do you think we are on this stuff?
Well, you know, it is a question of apples for apples comparisons, of course, and if we're saying equivalence is the day that we can buy a car with an identical range as an EV as it does as an IC engine, I still see that as a little way out. I think in the mass market, I think that's difficult, because mass market cars typically do have you know, pretty good range already, because the amount of space available for a fuel tank is a function of the dimension of the car. And you know, we're building cars certainly with pretty small engines with, you know, 50 plus mile per gallon, easily attainable fuel economy. So, you know, are we going to see, you know, 500 miles from a tank full of electricity in a car that's a sub £20,000 car? I don't think so. But we are managing the expectations of the user to the point where the convenience of refueling that car, you know, the opportunity charging and the ease of overnight charging at home or workday charging, means that the accessibility of the range of the vehicle is always there. You're not waiting until, oh, well, yeah, I can go that distance, but only the day after I've gone to the fuel station and spent 10 minutes up to my ankles in diesel. So, you know, I think if we can talk about accessible and usable range, and we can stop people worrying about an absolute number, then we're going to get there within those few years. I think in the premium sector it's a bit different because there, the fuel tank size is a limitation, and we have been fitting smaller fuel tanks to some of those vehicles, driven by the fact that with diesel we can get away with it. But if all, in fact, Dave happened to know that you suffer the same issue. But when you own a gasoline engine vehicle, perhaps with a supercharger, the fuel tank doesn't take you very far if you're driving with any degree of enthusiasm, because we no longer fit 70-litre fuel tanks to cars, because we've packaged other things in the way, convenience features and safety structure. So it has become a limitation for premium cars, and the batteries might, if they're properly integrated into the vehicle, actually get us to a more proper parity. And I think that's where people like Lucid and of course Lotus's efforts are beginning to get us. That we're starting to reach that point. And the price parity issue, again, those are cars which have got a fair amount of adjustability if you trade one attribute for another in how you price them and how you deliver them. So as long as we put the range and efficiency attributes up high enough on the chart, and we give up a little bit of something else, then the clever engineering teams in those companies will get us to parity. Again, I think that 3 years, 5 years maximum is probably realistic. But TCO parity, I think, is probably here today.
So what does that mean then? And I'll ask this as Matt first, and then of you, David. What does that mean for the future of the plug-in hybrid? Does that mean that it no longer has a place if we're going to be looking at cost parity and completely acceptable range in a matter of a few years, or do we see that living longer in the market? And if so, what does it need to start looking like?
Okay, so plug-in hybrids, when I start comparing the overall offering that we can give a customer for a plug-in hybrid compared to a full BEV from sort of 2024, the performance is not on a par, the cost of ownership is not on a par, the mass is pretty similar, but it just doesn't give the same product offering. So when I see concepts that have 4 seats, 5 seats, performance that you just can't achieve with a combustion engine at that price point, and 2 full-size flight cases looking lost in the boot, the opportunities from an electrified powertrain just outweigh everything that you could do with a combustion powertrain. And then if I start to consider what we put into our cost models for providing battery electric vehicles to customers, so if I allowed myself to imagine I was in Elon Musk's shoes and had the entire infrastructure and ecosystem in place to recover all of the value from that car's battery after it's been used and redeploy it, so that I only need to charge the customer for 30% of the value of that battery, then there is no argument at all for any sort of plug-in combustion vehicles sort of the end of this decade and into the 2030s.
And David, how do you see that, particularly thinking around the kind of global markets that you're in?
I mean, we've as a low-end car maker, we've always been very nervous about all hybrid technology, to be quite frank, because it's all incremental cost. There's no substitution of anything, especially when you think of a PHEV. Yes, okay, maybe the battery is, in our case, half the size of the one we'd need. Perhaps in a luxury car, it's a bit, the saving for the battery is a bit less. But it comes with a commensurately short electric range, and if the whole point of these cars is to give you electric driving in urban conditions, we sell cars that mostly do drive in urban conditions. So you wouldn't be able to use to be zero emission if you were depending on a shrunk down version of one of our conventional BEV batteries. And the other aspect that we've got to think of is the lifetime operating cost and reliability. I know we're pretty good at reliability as an industry these days, but nonetheless, the number of failure points on a PHEV are significantly greater than the failure points on on a pure BEV. It's just a more complicated thing to do. And you've got 2 or 3 electric machines involved. You've got a lot more controls complexity, so things like calibration are much more complicated tasks to undertake, and more sensors to keep alive and service. And I just see that admirable though the achievement of some of these PHEVs are, I think they have been a transition point, and it would almost be futile for a new entrant to the market or somebody trying to attack one of their currently fully ICE ranges to go there right now. I think the lifetime, as Matt suggests, by the time you've started a program now, you're into 2025 or something before you're realistically launching it, and you've possibly only got, well, depending on whose government you believe, but 5 to 10 years before you might actually have even a ban on selling it, never mind falling demand. So we of course I'll be proved wrong by some product strategy announcement from our own company soon, but I don't see that there's a real future for complex hybridization in emerging markets. I do see there might be a stopping point for some mild hybrid, which isn't there at the moment because we haven't really embraced that yet. But it would have to be 48 volts. It would have to be a decent amount of mild hybridization, but perhaps without significant onboard storage. But as soon as we've got 10 kilowatt hours of battery, I can't afford to buy another couple of motors and a drive shaft and clutches and all the exciting things I need to make a PHEV work.
So it's interesting because some of the previous sessions were talking about PHEVs and whether we should be aiming for larger batteries in them. And I think, from what you're describing, the answer is yes, make the battery so big that there's no engine anymore.
Absolutely. Yeah. And it's a mass equation as well, that shrinking down the IC engine somewhat saves some weight, but the transmission that has to go with it, or the transmission and motor unit that goes with it, is a bulky thing. It's got shafts and drive systems sticking out all over it. It's got some high voltage cabling, which itself has got packaging nightmares. So I think Dave, you may have actually seen it, but we built a range extended version of one of our vehicles, a small compact sedan, and the underhood was a complete nightmare. And running it as a prototype was a disaster because every time we touched one thing, we had 4 coolant loops on the car. We couldn't, nothing. I only drove the car about 10 minutes in its entire life because every time they tried to show it to me, something broke. So, I know. Okay, that was a prototype, not a production car. But the service issues of those vehicles are fantastically complicated. The service issues with battery vehicles are solely related to keeping the electrons in their right hole and making sure that our safety interlocks are all robust. Once we've done that, the rest of it is so simple by compared to something like a PHEV. And I certainly wouldn't want to see a PHEV with a battery that's 60 or 70% of the battery size of a full BEV, because then it all becomes pointless and the cost equation is just, for me, completely out the window.
So that suggests, if we look at what Formula One is doing at the moment, they're sticking close to their IC engines. They like the noise. So does that mean that the days of Formula One filtering technology into road cars are becoming increasingly limited, do you think? Matt, what do you think?
I'm loath to say no to anything that's generated a combustion engine with 50% thermal efficiency.
Yeah,
that's quite an achievement. Also, we're looking at the thermal management and the battery units, the chemistry investigation. Yeah, there's opportunities there, and actually, whilst we've said PHEVs for a long-term proposition, possibly not going to be competitive with BEVs over a more longer duration, there's a mid-term proposal for companies that have already put some investment into plug-in hybrid systems. That I think there is realistic proposal of generating a return on investment for taking more of a systems engineering approach to some of the combustion systems. So how do we waste less energy? How do we optimize the combustion systems better for a proposition that has availability of electrified torque? How do we take some thermal inertia out of the after treatment and boosting system? So I think there's still an opportunity for some Formula One technology to filter down into what we see every day.
I think perversely, though, I mean, Matt touched on the thermal efficiency, you know, that second only to ship engines. I think Formula One engines are the most efficient IC engines on the planet. And certainly in road vehicles, I think I've seen a couple of presentations from Formula One management that suggest that they're champions of ground vehicles. But what they will do, I think, is help the dying embers of the IC engine industry to not kill us all quite as quickly, because the drive towards synthetic fuels, I think, will be something that Formula One can help us with. Because I think they're going to pioneer that quite soon, and when you pile it on top of some of the the e-fuels work that's already been going on, it'll raise the profile of cleaner, greener IC engines. But the Formula One world are not going to embrace major energy storage on board. They might be looking for power. They might be looking for the short-term power benefits. But it's in and out stuff, that's in the course of one lap, it's up and down. So their battery chemistry and battery management issues are quite different than road car. Formula E is, of course, a slightly different case in that they've now, doubled the battery, so you don't have to stop and change cars halfway to, on your trip from London to Birmingham, you don't have to stop at Watford Gap and get a new car. This is good news, but. And I think over time we'll start to see things like electrified endurance racing as a feature, and of course the trend of endurance racing towards hypercars anyway will mean that will collide with the electric hypercars coming at them from a fairly high rate of knots. But Formula One, I think, is going to get stuck in a slight corner in that it will be entertainment more than engineering excellence. And there will be plenty of engineers employed, but they'll still be employed to beat the rule book rather than truly move the needle.
So let's fast forward that motorsport piece a little bit then. So I mean that's really interesting. Hypercars coming into the kind of motorsport space more than the bespoke motorsport options. But you mentioned earlier, the long-term trends are for connected and autonomous as well as electric. So Matt, I'm interested. You mentioned earlier that the way that you keep your Lotus products relevant as hypercars isn't just going to be around the powertrain. So how do you see that whole autonomous and motorsport and electric all somehow coming together?
If you'll allow me, I'll cheat slightly and start off with the motorsport part. In reference to your previous question of Formula One filtering down, if Formula E or electric hypercars take off, then there's really good opportunity for drive engagement between those products and ours, or sorry, those competing vehicles and ours. And I think that would really help to drive some innovation. If you've got multiple torque sources and a control system that has to choose between them in the most optimum fashion, that's going to help to generate some useful output. If you've, as we already see from Formula E, you've got a requirement to conserve energy, then that can read directly across and drive some engagement there. Connected vehicles, there is plenty of opportunity for different ways of engaging the customer for us. So if we start to consider charging, right, what can we do with charging? Well, that gives us, as Tesla again have already started off doing, the opportunity for energy provision and a new level of engagement with the customer on their supply of energy and the way they use energy. So we've offered them the opportunity to save money by taking energy off the grid only when it's a minimum cost. So that's another lever we can start using to engage people with our products. And then autonomous vehicles. So So for me, autonomy is about usability, as well as, if you use other people's examples, the ability to generate additional income. So that's more affordable. That's got to be good. And then things like torque vectoring. That can, so currently it's a real struggle to deliver dynamic capabilities of vehicles that are also efficient. So there's an EV by a UK manufacturer that doesn't perhaps deliver the efficiency that other people would expect. And what's not come across as well is that's a balance between some of the dynamic capabilities that are built into that vehicle. So it really is a compromise, and when we bring torque vectoring in and lay that over the top, it gives us another level of freedom to tailor the driving characteristics independently of the fundamental setup and geometry of it. So there's opportunities in autonomous, there's opportunities in connectivity, and there's opportunities in the fundamental technologies of the powertrain as well. And it's all not, it all works with the hypercars and sports cars.
Yeah, I'll bring the sort of less hypercar related bit on a story in there, and of course, you know, the ACES agenda that we're on, or CASE, or whichever version of the spelling you want. I think there's a very natural fit between electrification and autonomy, because electric vehicles are fundamentally, from a drive-by-wire point of view, rather easier to interface with than IC engine cars. They switch, you switch them on, you have a rear stat that tells you to go faster or slower, and they stop when you cut the power. So I think, you know, we've got used to the idea that creating autonomous vehicles out of electric vehicles is a perfectly acceptable thing. And I think when you look at where the easy wins are going to be for autonomous vehicles, which certainly is not high-speed highway operation, because it's just bringing too many challenges. And I think everybody who's announced, you know, grand initiatives in that, you know, 4 or 5 years ago, almost to a man, have all backpedaled. You know, I mean, Mercedes was, I think, the biggest climb down. You know, they were all over it, and then all of a sudden it was like, well, no, we don't see this coming in 10 years. So anyway, not picking them out at all. They're absolutely right. We have, you know, spent 3 years trying to get to level 5, and we kind of got to level 3 in a bit, and said it's still quite risky. But for low-speed autonomy, then, you know, sensible electric powertrains, and, you know, talking less than 50 kilowatts perhaps in terms of power, batteries of, you know, sub 50 kilowatt hours certainly can give you some very interesting autonomous solutions for both passenger transport and also, of course, urban delivery, which is, you know, we've all come to depend on in the last 6 months. You know, it's the man who arrives at our door and brings us our life. Should be arriving at the door in an electric vehicle, and that isn't going to be anything with an enormous battery or an enormous motor, or that can get to 60 in 2 seconds. This is a sensible conversion, and when you add some autonomy or connectivity to that type of vehicle, you've suddenly created a very, very green story, and one that's got potential benefits to public safety. So, you know, I think we can bring all these things together at certain points in the automotive spectrum. Whether, you know, high performance cars and autonomy make any sense, you have to be a pretty creative marketing type to, you know, to create that the use case in which you can do that. And, you know, I know we've talked about you know, the virtual racer versus the real racer and all of these things. You know, I can see, as an enthusiast, I can see some imaginative places you could be, but they're pretty much force-fitted. You know, the technology is pretty much force-fitted into that world. If you're making a car that's fun to drive, the fun comes by being connected to that car through a set of controls that have been developed by somebody who really knows what driving's about. The seamless torque you get can make a car very fun to drive, but you know, it's not going to be autonomous, and I think that's you know, that's a problem that Matt and his marketing teams will have to deal with, rather than the average man in the street.
So that makes me think that actually for the average man in the street, the thing they care about doing really fast in their car is probably charging. Yeah. So how far do we think we can push that, Matt? From the technologies that you're looking at, if we were to fast forward to, I don't know, 2030, 2035, how quickly do you think I can pull my car into the service station, take it from 5% to 80% and be on my way again?
Yeah, without delving into the treacherous depths of what comes out of the battery industry about charging times, we've seen 5 minutes on some cells. They're not something that we would put in a production BEV, but there's opportunities to optimize and get close to there with something that's more sensible. If we look at product offerings in the near term, 20 to 25 minutes for 5 to 80%. And that makes it a very usable product proposition then. But again, we're coming back to efficiency. I really don't want to talk about charging times and percentages. I want to talk in kilometers an hour, and I want to enable that with a drive system efficiency. So rather than go and force a compromised battery chemistry to achieve a charging performance, which happens not that often with the long range charging, I'd rather have a more efficient drive system realized through control, fundamentally better materials and architecture, aerodynamics, mass optimization, functional integration to get an overall more efficient vehicle and achieve a really high kilometers an hour charging rate through the way we use that energy when we take it out of the battery.
Yeah. So we just need fewer kilowatt hours in order to go that distance.
Just makes everything better.
So if I can do that 5 minutes charge, I certainly don't need to be carrying 500 miles of battery around with me, because I can't drive 500 miles without a 5-minute stop. I don't know about anybody else. So how do you think, what sort of size battery do you think we settle on at that point for the average person? Or not size battery, let me put it in terms of range. Maybe that's your point on efficiency is well made. That if we talk about it from the user's perspective, what range do they realistically need at that point?
So I again touch back on something I mentioned earlier, which is the ownership and the cost model. We're all telling the government at the moment how much we need battery production capability and how much we need the costs to come down, and the number of industries winding up on the use of batteries is absolutely fantastic. But if we can realize a circular value chain for a battery system such that we can overnight wipe out 70% of the cost that we have to pass on to the customer, then the pressures on that battery system that goes into a vehicle dramatically change. Now, it's a long shot hoping for that, and we're not able to plan for it at the minute. But if it was enabled by a combination of design changes in the business ecosystem, partnerships and government support, it would be really good to jump on that as fast as possible. Hence, I struggle to answer your question because I'm trying to keep an eye on all the different things that are happening, and that would be a really big one that would change all of the concepts upon which we base our assessments of what's okay for a vehicle battery size, what's a good product offering.
That makes complete sense.
The other thing we've got to think about is that the energy loss in very high rate charging is inevitably something that we need to worry about, and that some of the descriptions I've seen, and bear in mind that I'm a simple mechanic, I'm not a clever electrical engineer, but the I²R story to me suggests that if we're pumping 350 kilowatts or 800 kilowatts or something down a lump of copper, the chances are that there might be some heat involved, and so we've got to be, in measuring our efficiency, we've got to be just as aware of the tank to wheel story as the IC engine industry has become in having its arguments about efficiency. So if we take tank to wheels literally, and it's everything that we get arriving at the charge socket, and we don't care how it's got there, even the immediate, Dalek standing by the roadside, or whether it's the grid, then we as vehicle engineers can say we've done our job. But the truth is, if we demand, a network of 350 kilowatt chargers or more in order to feed these 5-minute or 10-minute or 15-minute charge times, we've probably missed a trick, and all we're doing is passing the problem on to ABB or somebody who's got to build chargers that somehow break the laws of physics. So I think having a more modest approach to things starts to make an awful lot of things an awful lot better, an awful lot quicker, and it spreads the accessibility of these vehicles. I can't, with going back to our situation in India, for example. The grid in India is becoming a lot better than it was. I've been traveling to India for the last decade. When I was there originally, brownouts and scheduled and unscheduled power cuts were simply part of the equation. The last few years, most larger cities have actually solved that problem, partly by the grid capacity increasing and partly by massive investment in particularly the local robustness of the grid. But if we start to put even 50 kilowatt chargers onto that grid, we're going to have to put a whole new layer of investment onto it. And I appreciate the West is probably better able to do that, but even then, the predictions about your average London street will go brown if you've got 10 EVs plugged in down on the same substation. We can't afford super high rate charging. So I agree with Matt. We've got to be follow efficiency, and it's what I came into this session pitching, and I still think it applies across everything, whether we're talking about a Renault Twizy or whether we're talking about a 1500 kilowatt hypercar. If they're not efficient, we're not actually serving the planet.
And what that says to me is that the battery, the trend in battery development has all been pushed in recent years around more and more energy density, obviously trying to control cost within that. But really what you're suggesting is if we can move to these more modest, highly efficient, small batteries, lower range, easy to charge, 5-minute charge, I would certainly love that. Plenty of performance, all from this relatively modest package, then we can solve a lot of the problem that we've had with electric vehicles, which has been around the cost of the battery, by really looking at the externalities. And maybe the need to be looking at radical changes in chemistry is not so great anymore. In fact, as you were saying, Dave, you can be stepping back from some of these more exotic, low cobalt NMC materials, perhaps back to previous generations of lithium iron phosphate and those kinds of things.
Yeah, it's not one size fits all by any means, and of course, there will always be niches, as there are today, for exotic things. But I do think that the key to success in this new powertrain industry that we're creating, where every component is unlike any component that we've made before, we've got to collect together our requirements into reasonably large heaps in order to make anybody make money out of supplying it. So there have to be families of powertrains that are largely similar to each other. And I think the moves we've seen in the sort of drive unit industry have shown us the way to go. 10 years ago there were lots of small innovative companies creating wildly differing versions of topology and magnets and coils and all sorts of things that were coming out of their imagination. They were not coordinated. Nobody had scale. Some of them were brilliant. Some of them were terrible. But they were all out there. What's happened, of course, is now the consolidation that's gone. Is that we're actually seeing companies that are existing large-scale automotive tier one companies that get the whole ecosystem that goes around supplying anything to the automotive industry. You have to make it in volume, you have to make it reliably, you have to supply support in spares and warranty and all the rest of it. All of that being then brought alongside the creativity of the initiators of those will mean we start to see families of components, families of batteries, families of power electronics that are actually scalable, and where a small car will actually directly benefit from the learning from something very exotic and very high performance, it'll trickle down faster than it would at the moment. So that's what I'm looking forward to, is a much more integrated supply chain.
Fantastic. So I'm aware that we're coming towards the end of our allotted time, and we've covered a huge amount of ground in the last hour. I've been scribbling as we've been talking, and I have to say it's really interesting for me that if we'd been talking a year or 2 years ago, I think the predominant feeling would have been around engineering cars for more range, pushing energy densities up, looking at high performance vehicles for the everyman. And yet what we've talked about today is almost the diametrically opposite of that. We're saying, look, actually, now that this industry is starting to mature and we start to know what we look like as a mature electric vehicle industry, it gets back to basics. This is all about how do we get to something which is affordable, more efficient, to get smaller batteries. If it's smaller, it charges faster, so you don't need 350 kilowatts anymore. Actually, you can charge your small battery on a 50 or 100 kilowatt charger in an acceptable time. And if we can be frugal with our materials and recycle, you're almost just leasing the depreciation of the material to the user rather than selling them a battery and worrying about disposing of it at the end. And then linking all of that together to give economies of scale that are reusable across platforms. For me, it's really exciting as exactly what we were hoping from today. An industry leadership, a thought leadership piece. We're not heading the same direction that we were a couple of years ago. And actually, that's got some quite profound consequences for the supply chains, for the manufacturers, and hopefully for the customers who'll be able to buy these vehicles cheaply and get what they need from them. So, David and Matt, thank you very much for today. It's been a fantastic session, and please can I hand over to Peter to wrap up for us?
Well, a very special thank you to all of you. That was a great session, and thank you very much, David, for steering it.
Thank you for having us.
It's a pleasure, and we hope and look forward to seeing you again. I've mentioned before we are looking at a global automotive week from the 7th to the 11th of December, where people have the opportunity to pop in and pop out as they wish in order to carry on with the day job, but to also introduce into that and probably a couple of later sessions as well, so that we can actually pull in more from America and sort of different parts, so we can literally have a global discussion on some of the key points. But that was amazing, and it transforms with what you've discussed some of the major challenges for me that we were heading towards on infrastructure. I know in England we're fairly unique in the fact that there are lots of properties that don't have home charging, and there's a lot of off street. But with the solutions you're coming up with, it moves people far more towards EV than they would have thought. So thank you very much indeed, all of you, and keep safe. And one day we will get to meet face to face again, ideally at Warwick. But until then, needs must, so to speak. So thank you.
Have a very good weekend. Thank you very much.
You too. Thank you.
Thank you.
Thank you all.
Thank you.
Thanks.
Thanks.
Bye. Bye.